Hello, welcome back to Dev Radio. I'm here once again with Vishnu Pamula. Lucky, glad to have you. And today we're going to talk about MLOps and large language model ops with Azure Machine Learning. Large language models are mind-blowing. You can do some really impressive things with them. And if you want to, use them in production, in a full-scale real-world app, you're going to want to streamline deployments. You're going to want to really get things dialed in on the ops side. So, what tell us about it?
Wonderful. Thank you for that initial thoughts, Matt. You're absolutely right. The large language models have proven that they can they can accelerate productivity and so on. So we've seen the value. The next steps are basically thinking about how do we deploy these models in production? How do you maintain them, monitor them, so that these models give us the best performance and best outputs, and also safer outputs, and so on. So managing them, deploying them, monitoring them is the next ask from the customers, and we have a pretty amazing capabilities with an Azure machine learning, which I will be demonstrating today. By the way, my name is Vishnu Pamula. I go by Lucky. I'm a cloud solution architect at Microsoft, supporting the data and AI technologies. I'm also AI ML champ inside the company, and we also have Azure Quantum Service, which I'm an ambassador. If there is an interest, please reach out to Microsoft. We'll be happy to share. And I love teaching. And I teach as an adjunct, and I also have a course launched on Udacity. The objective of this session is learn how MLOps streamlines the classical machine learning models. I won't go too much details into that, but I just want to give you an overview on how the MLOps works, so that you have the background of how it works. And then I will cover how MLOps can support the same capabilities, automation capabilities for large language models, which is called LLMOps. Here is the detailed agenda. I'll start with why concept, like why MLOps, why LLMOps, and how to do that LLMOps and MLOps and using Azure ML, how to do the automation using GitHub and also Azure DevOps, and how do we monitor the data and models within Azure machine learning, and finally generative AI capabilities and how to deploy the foundation models, how to tune the prompts, and so on. If we take a step back and look at how the models work, we have the data, and then we have the applications. Applications historically have been used for delivering the insights to the users based on the transaction data or the analytical data. When we infuse the ML models into the architecture, ML models take the data, and we call it as a training data, and it makes the predictions and it feeds into the application. If you compare how these two pieces of software works, the applications and the ML models, for example, how to detect spam emails. In the applications, we feed the algorithms and heuristic rules. For example, check for specific keywords, check for IP addresses, ranges, and so on. The keywords include like free, weight loss, and you won lottery, and so on. Based on those cues, we flag that email as spam or not. In the machine learning, we take the training data and we label the data as spam or not spam, and then we use that data to train the ML models. And based on that, it predicts. So the classical applications are deterministic. It knows exactly what to look for. ML models also are based on the training, but they make predictions. So those are probabilistic models. Since they are probabilistic models, it could become a problematic because data might change. You might see bias in the data. You might see fairness in the data. So we have to, handle these models properly using, MLOps. So what else we need to monitor with ML models? We need to monitor the data for the drift, which is basically the change in the data from what was trained for the models and what's new, that the data coming for making the predictions. The models itself can drift, model performance, how it makes the predictions and the accuracies and so on. And explainability, like you deploy a model for a specific purpose, and we want to make sure that the model is not excluding certain group of people. That's called responsible AI. Microsoft has got a pretty fantastic mix of responsible AI framework. So we need to monitor the models for these the features, fairness, error rates, and so on. And finally, the infrastructure itself, like you deploy a model to a container which sits on a virtual machine, for example, in a container, and we need to monitor, like, is it so busy serving the clients? Can we scale up? Can we scale down? How much memory and so on? So considering all these capabilities, we need to monitor, and we need to monitor at scale. So that is that is needed for this ML models. Fortunately, we do not have to reinvent the wheel. So we have seen how DevOps can be used for ML models with continuous integration, continuous delivery, where we bring the people, processes, and platform together to develop the code and go through the process and deploy it, monitor, and so on. So we can use the same principles for ML models as well. So that is called MLOps. The life cycle of an ML model looks like this. You prepare the data, you train the model, build the trained model, deploy it, and monitor it. And we have various personas involved in those phases: data engineers, data modelers, data scientists, ML engineers, and so on. If you look at the steps involved in those phases, we have prepared the data, cleanse it, transform it, and so on. You build the model, do the feature engineering, train the model, make it better, tune the model with the parameters, and make sure we do these experiments repetitively. See, build the pipelines that are repeatable, and so on. You validate the model, package it, and deploy it. And once it's deployed, you monitor for drift, data drift, model metrics, A/B testing, and so on. And how about large language models? The process is pretty similar. If we see the differences between ML models and large language models, the large language models come with the pre-trained models. They've been trained on large volumes of data, so they know how to give the outputs based on the question you ask. You send an email, sample email, it will be able to classify the email, is it spam or not. We don't have to go through that expensive training. That's where the problem could be if we don't manage these models well. Especially, you might have heard about prompt injection and hallucination and so on. These models give you the output that you may not anticipate. That's where we have the opportunity to control how the models respond for a question. For example, I just asked a GPT model, what is LLMOps? It says a lifelong learning machine operations. So, but if you give some context to it, it might give you the right output. If you look at the life cycle of LLMOps, it's pretty similar to classical ML models. Only difference is we do not have to train these models from scratch. So these models are already pre-trained, so we don't have to do the feature engineering and so on. But we still have to prepare the data, cleanse it, transform it, and once it is done, you can use that data to ask the questions from the models, do the prompt engineering, find the right prompts using fine tuning and so on, prompt tuning. And in some cases, if you want to do a domain specific build the applications, you could deploy, you can fine tune these models further to get the answers for those specific domains. Everything else is same. You can still tune the large language models like temperatures and learning rates and so on. We can still build the repeatable pipelines, validate and deploy the models. And once the models are in production, you can monitor for the drift and how the model is giving you the output and so on. And Azure Machine Learning is meant for that capability, giving you that end-to-end machine learning lifecycle. Preparing the data with data preparation capabilities. You can access like tons of data sets, variety of data sets, structured, unstructured, and so on. You can have the labeling capability. You can you can do the labeling with the AI assisted the interface. And we have the the capabilities for building and training the models using notebooks and AutoML and so on. The validation and deploying phase where you can build the you can take the models that you have built and you can deploy as an endpoint. You can build the CI/CD pipelines and so on. And once the model is in production, you can monitor at scale for data drifts and model monitoring capabilities like tracking and logging, analyzing data, and so on. So there is an accelerator that Microsoft has developed. It's called Microsoft Azure Machine Learning MLOps V2. This is a busy slide, but I'll try to keep it simple. What this does is it applies the MLOps processes where it helps build the models. We call that is that as an inner loop where you build the model, do the experimentation, and so on. And once it is trained, you take it to the production, you deploy it. Once you deploy it, you have certain steps to follow to process the model, monitor the model, detect the data drifts and model drifts, and so on. So that is called outer loop. So this MLOps V2 accelerator brings these inner loop and outer loop together under the MLOps framework. So I will be doing a demo on this MLOps GitHub repo. Before I show the demo, I wanted to cover the generative AI capabilities within Azure Machine Learning. This is the slide from Microsoft Build announcement in May. We have announced pretty breathtaking capabilities, bringing the generative AI capabilities inside Azure Machine Learning. For with the foundation model catalog, where we deploy all the base the models, and prompt flow tool, which is which will help us with prompt engineering and tuning the prompts and so on. A content safety to detect the the risks in the data, and scaling of the AI model, generative AI models, and deploying them, and also monitoring them, and so on. So the foundation models, we have the various models that are curated by Azure, the open source models from Hugging Face and Azure OpenAI models, and the Llama models as well from Facebook. And you can just with a simple piece of code, you can deploy these models, you can tune them, and so on. And with prompt flow, you can create pretty sophisticated prompts that give you the best answer from your data, and so on. I will demo this in a bit. And finally, There is also another feature called RAG, which is a retrieval augmented generation, where we can ground the LLM models with your data, which can effectively give you the answers. So this process works just by using the prompt engineering. We don't have to do the fine tuning, train the models. Just have to use the prompts, and it learns how to respond. So this process works like like taking the data, creating the chunks using LangChain and custom coding, do the vector embeddings using Ada and so on, and store these vectors in a database where you can you can effectively ask the questions on your data. So Azure ML provides the RAG workflows, which I'll show in a bit. And we can also try the another feature within Azure AI OpenAI Studio. It's called Chart on Your Data, where you can just connect your data and then ask the questions. Pretty pretty amazing. So with that, I will jump into the demo where I'll demonstrate how these MLOps works for the classical models, and then I'll show you how the large language models can be deployed and monitored.
Great, the demo's the best part.
Yeah. So with this, I will use GitHub Actions. It's the same process for Azure DevOps as well, but I will be using the GitHub for this demo. The first thing we need to do is connecting the Azure portal, Azure ML workspace with GitHub. So we need to create something called app registration, which will give you specific parameters like the client IDs and tenant ID and secrets, which you can connect using your apps. So you would come here to the portal and create the app. Then you take those values and go to your GitHub repo and add to the settings in the actions and settings space, secrets and variables like this, like clients and secrets and subscription IDs and so on. And once we have that, you can write your code and you can run the pipelines to deploy the models and so on. So this is a repo that our Microsoft colleagues have developed. This is an accelerator, MLOps v2 accelerator. So I did a fork on this, but if you want to go to the main one, you can do so by using searching for MLOps v2. And what this repo has is that it's got the different folders inside it for deploying making the data connections to the data sources, deploying the infrastructure and so on. And there is also nice documentation that you can follow. And if I go to the workflows, we have the pipelines to deploy the initial infrastructure, like deploying the Azure Machine Learning workspace and resource group and everything. This pipeline does it for you. And this is based on the Terraform, so we can just follow it. And you just run this pipeline, and which will deploy everything that is needed for this. And then you can use the deploy online endpoint if you want online, or you can deploy the batch endpoint. Before you do that, you have to train the model. You can run this pipeline. So if you go to the actions, you will see that I ran these pipelines already for you. And you can see that everything is set up in the Azure Machine Learning Studio. So if I go to my Azure Machine Learning Studio, let me switch to this workspace. So this is where you will see the infrastructure that is developed and that is deployed, model that is deployed to this, and also finally the endpoint, everything. So first I'll show you the infrastructure that is needed for this. So it created the workspace, machine learning workspace, and after that it deployed the ML model that's in that repo. You will see that model here. It's called taxi model. And after that, it deployed the endpoint itself. So this endpoint is called like this taxi model, and you can test it. You can test with your UI right here, or you can use the notebook. Can show you the sample notebook. So what you would do is you grab the keys and then the endpoint name, and you just invoke from here. So it's a it would pass your data, and then it will give you the output. It's pretty easy. So the same process can be used for large language models. So what we did was we have another repo. I mean, this is my own repo, and there will be an official repo that will be published. But right now there is community developed the repos to deploy the prompt flows into Azure ML Studio. So what this is, how this is structured is that it follows the same process. You deploy the infrastructure, the resource group, machine learning workspace, and everything, and you build the model. Model means like prompt flow model. You can do that using a Visual Studio Code. I'll show you an extension that's needed for building the prompts. So while it loads it, I'll explain like how this is structured. So this repo we have a tab, a folder called workshop, where we combine the prompt flows. The prompt flows are very similar to what you see in the ML Studio. If I go to the my workspace here, let me quickly jump to my personal workspace. So this is the homepage of Azure Machine Learning. You will see the model catalog, which is the foundation models, large language models. And if I show you what's available there, so we have curated models from Llama, Falcon models, Hugging Face models, OpenAI models. All you have to do is select which model you want to deploy. You can also filter by the specific categories here, like text classification, Q&A, and so on. And you just select the model and you deploy it, and it will give you the code also along with it. And there is a nice GitHub repo that I can point you to this one, where if you go to the SDKs folder in this, and there's a pretty nice sample the code there, Python, .NET, and TypeScript as well. You have the foundation models tab and generative AI tab. You just pick the foundation models tab, where you will see a lot of samples, Hugging Face samples, OpenAI samples, and so on. I'll show you one sample Llama model deployment. Again, there's a lot of samples here. I'll just show you one text generation example using Llama models. So this notebook gives you a sample code for deploying the Llama model within Azure Machine Learning, and you can just you can deploy as an endpoint, and you can do the Q&A with it. If you follow these instructions all the way till the end, you will be able to deploy the model. And the prompt flow is what is more interesting. This is what helps us build the right prompts for your data, and also you deploy the model, the prompt flow as an endpoint. If I open one of these prompts, maybe if I go to the create, we have a pretty good examples already available for you. You can start a chart flow where you can do the Q&A on your data, and some examples from from the community like Wikipedia, asking the questions from Wikipedia data, chart on it, classifying the web URLs and so on. So we have pretty nice examples, including the retrieval augmented capabilities as well. So Q&A capabilities. So we can just open one of these and follow the instructions. It will deploy the prompt flow like this. So I'll show you one web classification example. So what this does is you pass the URLs to this model, and then you pass the couple of samples of the prompts, and then this model gives you the best prompt that works for this type of data. You see nicely, you can use the UI to create the variables and inputs. You can link the Python code here to extract the data from the URL, and then you can link the OpenAI models here, and you can see a very nice prompt flow right here. Once you build the prompt flow, you can, if you want to use the UI, you can still you can use UI to bulk test it to find out the best prompt, and finally you can also deploy as an endpoint right here. And when you do the bulk testing, basically it will give you the best the prompt that works. So this is where you would be tuning these prompts, finding the best prompts, and so on. And you can see the metrics here, how much accuracy it got, and so on. Pretty interesting and amazing. So right now, so this is the UI. We'll be releasing a GitHub repo, official repo for this. But right now there is a community developed repo like this, where you can you can use my repo, or you can follow the repo that I forked from, and then you can use tools like VS Code to build the prompt flows in VS Code. So what I did was I forked the I cloned the repo, and I installed an extension for VS Code. It's called prompt flow extension. So you would go to the extensions and you install it, and then you will be able to create a prompt. If I go here, you can create the prompt. It's a bit slow today, but once you get here, you'll be able to start creating it and give you some samples, and it will show you a nice flow like I'm going to show you in a bit. And so this is the code behind the prompt flow, which has the all the steps like you see in the UI here, with all the steps like input variables and where you call the OpenAI models and so on. And this will also give you a nice visual editor where you can do the flows. For some reason, it's not showing that now. On the top of the file, it will show you the visual editor, which you can see exactly what you see here in the prompt flow. So once you think it's coming up, but when it comes, I'll come back here and show you how the visual editor shows here. But what I'll do is I'll try to show you the GitHub repo. That is that. Oh, there it is. My laptop is a bit slow today. See how nicely we have built this prompt flow within the prompt flow tool within VS Code. Now you can just go to this plus button here. You can add the input variables. You can add the Python samples. You can add the large language model category, all of it. And then the moment you add and link these pieces together, it creates a very nice flow like this. So once you're comfortable with this, and you can test it right here. You can using the running right here. You can debug it. You can find the issues in the flow. You can publish it to GitHub, and then from there you can run the pipelines to push it to the Azure Machine Learning Studio. That is what this report does. And if you go to the actions and show you the pipeline that I ran already. And it works nicely. There are some runs that were failed, but this does the deployment of the endpoint prompt flow endpoint. So once this pipeline runs, what you see here, if you go to the Azure Machine Learning Studio, you will see that the prompt flow has been deployed successfully. So this is the endpoint that I deployed using the same prompt flow that I built in VS Code, and I put this in the GitHub repo, and that's deployed into Azure Machine Learning. You can test it from here. So everything is there. Everything is green. You can just integrate into your applications. You have the endpoint, and you have the keys, everything, and then you can go from there. So that is about deploying the foundation models starting from the model catalog and building and deploying the prompt flows. And finally, how about the monitoring these models? Azure ML has got pretty interesting monitoring capabilities with monitoring the data and monitoring the models as well. So if you go to the data section, you will see in the data set monitoring section, you can monitor for the data drifts. What has changed from the baseline? So you said you upload the baseline, and then every time there is a new data coming in, it understands and it finds the differences. So in this, I don't have the right data, but I can show you some sample screens that you will see when you put your data. Like this, you can monitor for the data drift, like you set a threshold of 20% of each variable, and then you monitor, for example, like temperature. This is a weather data, and you see the temperature, origin, and everything changed. So we're able to track those changes, and even you can see the data drift over over time period, and you can see the drift by feature as well. So all these, the samples are available on Microsoft documentations. You can search for data monitoring in Azure Machine Learning. You will see. And finally, how about monitoring the models? So Azure ML has got pretty interesting capability that is in preview right now, which will be in GA in shortly. And so what this feature does is you can monitor the model endpoints after you deploy it. For example, if you go to the add signal, you will see you can monitor the data for a specific period, and the same thing that I showed in the slides, but this is much more detailed. It'll have the capability to select your own algorithms and metrics and so on. You can monitor the prediction data, like what comes from the models. So you can monitor all the features or specific features. You can apply specific algorithms like this. And if the model sees the difference in prediction from what it predicted yesterday and what it predicts today, if there is a difference by whatever threshold you set, it will send you an alert, an email alert, so you can take action. So data quality also is pretty interesting. You can monitor data itself, like is the average changing, is max value changing, is there a lot of null values in my data? So all these data quality features are there. So pretty interesting features. Again, you can use this for classical ML models, but when it comes to the OpenAI, I mean the LLM models, you can still monitor what goes inside the models, what comes out of it. The data monitoring and the outputs and so on, but you can still apply use these features within Azure Machine Learning. And we also have data collection that we have enabled on other models. For example, you can monitor what enable the model metrics on the deployment. And if you click on this, it'll take you to the Azure portal where you can monitor for like how is your endpoint behaving? The infrastructure is healthy. Is it running out of memory? How many requests are coming in? How to do the load balancing with traffic management and so on. So all these capabilities are available. So you can just enable them and start taking advantage of. So with that, I will end the presentation. So I've covered the various aspects of it, like what is MLOps and why it is needed, and how LLMOps is different from MLOps, where we don't have to train the models, but we can still deploy and we can still tune the prompt flows and so on, and how to integrate Azure ML with repos like GitHub, how to build the pipelines, and how to build the prompt flow pipelines using VS Code, the extension, and using the UI within Azure ML Studio, how to deploy the automation of the prompt flows, how to monitor them, and so on, how to monitor the data drifts and monitor the model drifts and so on, how to track the metrics of these endpoints in the Azure portal using the metrics.
That's great. We covered a lot. Yeah.
Yeah, I'm really excited for this technology. It's still evolving, and I even wrote a blog about this, which is it's quite popular these days. So please feel free to read that blog as well. We will post the link in the comment section.
Yep. Yeah, I'll get all those links in there. And yeah, this is enterprise ready. This looks great. Wonderful. So thank you so much, and we'll catch you next time.
Thank you so much, Matt. Bye, everyone. Take care.
Bye.